Hello everyone, I'm going to explain a particular word problem type involving initial and final ratios. Let's see how this question can be identified, and I'll explain the good approach to this. In the first part of the question, there's an initial ratio given to us involving a certain number of items. Next, there's also a final ratio given to us. Between that, there's information about what happened. Certain number of items are taken out, added, or transferred. There are variations to this. Okay. So this question involves number of 10-cent to 20-cent coins. The common mistake, or the intuitive way that students like to start this question, which is also a mistake, is to see that 6 20-cent coins are taken out of the purse. Focusing on 20-cent coins, they identify that they see this number 5 here. And if you don't know how to start the question, most likely you will attempt to write something like 5 subtract 6, because 6 20-cent coins are taken out of the purse, and you get -1, and then you realize that doesn't make any sense. Probably thinking along the lines of money cannot be negative, or what does -1 20-cent coin mean? Okay, so the issue with this and why this doesn't work is because this 5 is not the actual number of coins. Not the actual number of 20-cent coins. It's just a number. It's like a number of units in the ratio. So where did this 3:5 come from? 3:5 is a ratio in simplest form. But if you talk about the actual number of coins, it may or may not be 3:5. It may or may not be 3 coins to 5 coins. And we can clearly see that if we assume that there are actually 5 coins, you can't subtract 6 coins from 5 coins. So in this case, there aren't actually 3 coins and 5 coins for 10 and 20-cent coins. Okay, so how does the actual number of coins look like while thinking about this 3:5? Understanding that when ratios are simplified, they get simplified to smaller numbers. For example, 3:5 could have come from 6:10, perhaps 9:15, 12:20, right? So all these are all multiples of 3:5, such that when they get simplified, they get divided into 3:5. Okay, so the actual number of coins is going to be a multiple of 3 and multiple of 5. How do we represent that? How do we represent a multiple of 3? It has to be 3 times something. And multiple of 5, it has to be 5 times something. So essentially, you can see that 3 and 5, if you multiply by the same number times something, you will get the actual number of coins. But we don't know what the actual number of coins are. We don't know what 3:5 is supposed to be multiplied by to get the actual number of coins. We can let x be the unknown. Okay? Such that when I say 3x to 5x, this is truly the actual number of coins. But with the power to represent this, the actual number of coins, we can proceed with the question. So initially, we started off trying to do 5 minus 6. But since 5 is not the actual number of coins, now instead, if we use 5x, is going to make sense. Okay? So let's tie all the information in the question together, and we're going to formulate a very nice algebraic equation. Ratios in secondary school can often be represented as fractions. So for example, 3:5, it's 3/5. Okay, let me just shift all of these to the side. So whatever I've written down is just a thought process, but the actual working will start now. We'll start with 3x to 5x. So this is a ratio of the actual number of 10 cent to 20 cent coins, just that it's written in a fractional format. Looking at the purple piece of information, 6 20-cent coins are taken out of the purse. We're going to subtract 6 20-cent coins from 5x while maintaining the fractional ratio format. Okay, so now let's see what does this fractional ratio represent. 3x is the number of 10-cent coins, didn't change. 5x minus 6 is the number of 20-cent coins after removing 6. So now, this number of coins is related to the final ratio in blue. Okay, because we have taken 6 20-cent coins out. After we have done that, the ratio of 10 cent to 20-cent coins is 1:1. It's equal to 1:1. We get this very neat and simple fractional equation, which we can simplify by cross multiplication. We can easily solve this equation for x, and we'll see how finding the value of x helps us answer the question. How many 10-cent coins are there in the purse? We know the number of 10-cent coins is represented by 3x. Hence, 3x is 3 times 3, which is 9. There are 9 10-cent coins in the purse. Alright, we're going to see one more example. I'm going to do the same highlighting. And this time we're going to do it more quickly, but same approach. Okay, so right now, the ratio of Charlie's to Jack's ages is 3:4. After, it'll be 8:9. What happened? 10 years passed. So we see, we take the starting ratio, write it as a fractional ratio, but the ratio 3:4 is multiplied by x, so now 3x and 4x represent the actual ages of Charlie and Jack now. In 10 years' time, so what happened to their ages? They all got older by 10 years. Add 10 to each of their ages. Maintain as a fractional ratio. So this is the ratio of their ages in 10 years' time. And we know, according to the question, it is equivalent to 8:9. Same way to simplify, we're going to cross multiply. Alright, so solving, we get x equals 2. The value of x is 2. Find the present ages. Remember the present ages, we started off with 3x and 4x. So, okay. Charlie's present age is 3x, so 3 times 2, 6 years. And for Jack, it's 4x, 4 times 2, 8 years. Alright, so there are loads of similarities between these two questions, but ultimately we can classify them as the same question type. You can see the question structure is exactly the same. There are 3 pieces of information that you have to identify and realize that is the same question type. And so we will always take this approach to solve it in just 1 to 2 minutes. Okay. Thank you and good luck.